Okay, so the challenge of this one is to decide what to do with cos 2x. Is it going to be cos square minus sine square, 2 cos square minus 1, or 1 minus 2 sine square? So obviously sine 2x is easy. It's just one option. It has to be 2 sine x cos x. There's nothing else you can do with it. 2 sine x cos x. But now this one, let's say we make it cos square minus sine square. Okay? Then you're going to end up with 4 terms. 2 sine x cos x plus cos square minus sine square minus 1. There's 4 terms. We don't want that. If you make it 2 cos square x minus 1, then you're going to have this part plus 2 cos square minus 1 minus 1 minus 1. Or 2 cos square x minus 1 and then minus 1, which is minus 2. And then that's also a bit much maybe. There's a better way, and that is to use 1 minus 2 sine square. That's going to be the easiest way to solve this thing. Otherwise you're going to take detours to get there. So we're going to change the cos 2x to 1 minus 2 sine square x, and then we just put in the minus 1. Now the plus 1 and the minus 1 cancel out. And then we get a sine x, and okay, let's first write that down. 2 sine x cos x minus 2 sine square x equal to 0. Okay, so now the 1 minus 1 is cancelled out. And now we can take out the common factor. 2 sine x, 2 sine x. And now we got a common factor. 2 sine x, and then inside the bracket, cos x minus sine x equal to 0. Okay, so we took out the common factor. And now we can say sine x is equal to 0 or 2 sine x equal to 0. 2 sine x equal to 0 or cos x minus sine x equal to 0. So there's our two options. Either the part in front of the bracket is 0 or the bracket is equal to 0. Okay. Now for this one it's the same as the previous one, because when you divide by 2, you're just going to have sine x equal to 0. So the point is, where is sine x equal to 0? The same as the other one. X equal to 0 plus 360 times k element z, or x equal to 180 plus 360 times k, and then k element z. So that's the solution for this one. That's 0 and at 180, and then plus 360 times k. Now for this one, you can take the sine x over, the negative sign becomes positive sine x. So then you got sine, and then when you swap the signs, you can say, or you can just leave it this side. Doesn't matter. Either way, you're going to get to sine x equal to cos x. And then what you do is you divide both sides by cos x. Okay? So with one like this, when you get sine x equal to cos x, you can say, okay, well, what now? Just divide by cos x. Why? Because when I divide both sides by cos x, we can change the sign of a cos to tan. Sine of a cos becomes tan. And then cos divided by cos is 1. So that's what you do there. Change the sine over cos to tan. And now you can figure out where is tan x equal to 1. It's at 45 degrees. Okay. So just use it on the calculator, and you're going to see x equal to 45 plus 180 degrees times k element z. And remember for tan, the period is 180. And for tan also, you only have one solution, not two solutions like for sine and cos.